Lesson number 91 is about the multiplicative property of equality and spheres. And our first question says to graph the solution, and we have this inequality. It says negative x is greater than or equal to 2, and our domain D can only be real numbers. So in order to graph this, we first need to solve for x. And since it's negative x, we just want x, we're going to have to multiply both sides of our equation by -1 to undo our negative. Or we can just move the negative symbol to the other side of the inequality. So what we're going to get is x, and then we move the inequality to the other side, and we get -2, not the inequality, the negative sign. And when we do this, we're making everything the opposite. We're making everything the opposite here, so we also have to make our inequality the opposite. So we have greater than or equal to. We now have to have less than or equal to in our answer. And that just helps make sure that we get our solution set graph properly. So this is what we want to graph. X is less than or equal to -2. And we only have real numbers here. Let's use red. So if we have x is less than or equal to -2, well, here we have -2. X is less than or equal to -2, so we've got our closed circle, and we're looking at real numbers, so we can include -3, -4, and we can include everything in the middle there as well. So our solution set must be going something like this. Remember to bold that arrowhead in to show that you continue that pattern as you go further to the left. So our note here, the key thing in this problem. When multiplying both sides of an inequality by a negative number, you must reverse the direction of the inequality. So that's what we did here. In order to undo the negative x, we multiplied both sides by -1. So we made this a -2, and we reversed the inequality. Let's practice a few more. Here we have 4 minus x is less than or equal to 6, and our domain is integers only. So first off, let's subtract 4 from both sides, because we're just solving for x. We're going to be left with negative x is less than or equal to 6 minus 4, that's 2. Now, we've got to multiply both sides of our equation by -1, or we can just move the negative over to the other side of our inequality, and we're going to get x is, well, we've got a -2. And our note, the key thing in this lesson, is to go ahead and reverse the direction of the inequality. So it's going to be greater than or equal to -2, because what we're looking for is the opposite of negative x is less than or equal to 2. Now let's graph it. We've got -2. It's a closed circle because x is greater than or equal to it. Now x is greater than or equal to -2, and we have to think about our domain. It's only integers. So if x is greater than or equal to -2 and we only have integers, we're just going to graph the integers along our number line that are greater than or equal to -2. So we'll follow this pattern out. We'll go all the way to the end of our number line that we have graphed. And we want to make sure that we bold our arrowhead in. So we show that we continue this pattern as we continue with our positive numbers. Let's look at another one. Here we want to graph the solution. We have -3x plus 4 is less than or equal to 13. And our domain, again, is all real numbers. So first thing we want to do, let's subtract the 4 because we're solving for x. Subtract 4 on both sides of the inequality, and we're left with -3x is less than or equal to 9. Now the second step, well, the second step here is a little bit different because we've got a -3x this time. So what we're going to have to do is we're going to divide by -3. And remember, dividing by -3 is the same thing as multiplying by -1/3. So we're dividing by -3, and the same thing happens because division of -3 would be the same thing as multiplying by -1/3. So we could call this multiplication of our left-hand side. If we rewrote it, it would look like this. -3x is less than or equal to 9, and we multiply both sides by -1/3. So our rule still applies here with what we do with our inequality. We're going to have to reverse the direction of it. So either way, either side we work on, we're going to get the -3 canceling out. X is going to be greater than or equal to, and 9 divided by negative 3 is negative 3. Same thing would happen here on the left. Negative 1/3 times negative 3 is 1. That cancels out. And we're going to get x is greater than or equal to 9 times negative 1/3, which must be negative 3. So let's graph it. We have x is greater than or equal to negative 3. We've got a closed circle, again, because it's greater than or equal to that number. We're looking at a domain of all real numbers. Be sure you follow your domain. So we're going over to the right with our solution set, and we'll bold that arrowhead in to show that we continue towards our positive numbers. All right. The second part of our lesson today is talking about spheres. And a sphere is just a three-dimensional circle. A sphere is basically like the Earth's shape. And we want to find the volume of the sphere whose radius in this occasion is 3 centimeters. So if the radius is 3 centimeters, we could draw the center of the circle here, the center of the sphere here, and we could say this is 3 centimeters. That's the radius, the distance from the outer edge all the way into the center of that sphere. Now to find the volume of a sphere, we use this formula. 4/3 times pi times the radius cubed. So let's work through that formula here. We have the volume of the sphere, V, is going to equal 4/3 times pi times our radius, 3, cubed. So it would look something like this. Let's put that 3 in parentheses to make it a little bit easier to see. Now we want to simplify as much as we can. Volume is going to be equal to, well, we have 3 cubed. We need to do that first. 3 cubed is 27. So volume is going to equal 4/3 times pi times 27. And this is really the same thing as 27 over 1. Now when we look at this, remember multiplication can happen in any order, so we can simplify before we multiply the 3 and the 27, because 3 goes into 27 9 times. So what we get is the volume is going to equal 4 over 1 times pi times 9 over 1. And we can simplify this to find our final answer. The volume must equal 4 times 9, which is 36. 1 times 1 is 1, so we can leave that out here because 36 over 1 is the same thing as 36. And we multiply that times pi. Now, you're welcome to multiply 36 times 3.14 if you like, but you don't have to. You can leave your answer just in this form. In fact, this is the most precise answer because there's no decimal rounding. So we're going to include our label of centimeters to the 3rd power. And we found the volume of the sphere. The key thing is that you get into your notes that the volume of a sphere is always equal to 4/3 times pi times the radius cubed. Alright, our final problem for today is to find the surface area of the sphere whose radius is 3 centimeters as well. So let's draw out our picture. We've got our sphere. The radius is 3 centimeters. So that's the distance from the center to the outside edge. And the volume of a sphere, this is not the volume of a sphere. I've copied that from the last page. The volume of a sphere, we know, is 4/3 times pi times the radius cubed. This is the surface area of a sphere. So I'm going to write SA for surface area. The surface area of a sphere equals 4 times pi times the radius squared. So if we use that formula here, 4 times pi times the radius of 3 squared, then we can find our answer. So the surface area, SA, is equal to all this. 3 squared is 9, so we're going to get 4 times pi times 9, and we know 4 times 9 is 36, so we're going to get 36 pi, and in this problem, well, in order to find our surface area, we get our number answer. We also have to get a label. So this one is going to be centimeters to the 2nd power because we're talking about area. And again, if you wish to multiply 36 times 3.14, you may, and you'll get the correct answer. But leaving it like this will also get you the correct answer. So I'll encourage you whenever we have a problem with pi to leave your answer in terms of pi. Be sure in your notes you've got both the surface area of a sphere written down for its formula, 4 times pi times the radius squared, and that you have the volume of the sphere written down as well, 4/3 times pi times the radius cubed. Our lesson practice will be on page 381. Make sure you've got your notes complete, and I'll see you during our next class.